Good morning, 11th standard. As all of you know that we started the chapter number 2, that is structure of atom. The existence of atoms that have been proposed since the time of early India and Greek philosophers, and who were of the view that atoms are the fundamental building blocks of matter. Okay? And then according to them we can say that the atom is further indivisible, but later on within a progress it comes to knowledge that atom is further divided into the proton, electron and neutron, from which the proton and neutron are present in nucleus, whereas the electrons are revolving in their surroundings, okay, in the shells. So for this, the various models of an atom was proposed by the scientists, and the models was first given by J.J. Thomson in 1898. He proposed that an atom possesses a spherical shape. ठीक है बेटा, कैसी shape? Spherical shape, whose radius approximately 10 raised to the power minus 10 million, in which positively charged is uniformly, ये देखो यहाँ पे, positively charged is uniformly distributed. And it was just he compared his model with the watermelon, in which the positive charge is maybe like a red one part of a watermelon, whereas the electrons, he just compared the electrons like the black color seeds which are present in this red color portion of watermelon. So red electrons are also distributed like in this, embedded into atomic model in such a manner so the giving the most stable electrostatic arrangement. Okay beta. So there were many names given to this model of J.J. Thomson, like plum pudding दिया गया था, watermelon जैसा कि अभी comparison में मैंने आपको बताया, और raisin pudding. The important characteristic of this model was that the mass of the atom is uniformly distributed over the atom. पूरे में distribute था, कहीं एक particular जगह नहीं था. So that was the feature of this model. Another one feature of this model was that atom as a overall is neutral, means there is overall or net charge on atom is 0, but that was also not consistent with the result of later experiment. लेकिन इनके मॉडल पर जब बाद में experiments हुए तो वो consistency नहीं रही. Thomson जो थे, that was awarded a Nobel Prize for Physics in 1906 for his theoretical and experimental investigation of electricity by gases. But yes, this model was not up to the mark of atom given by the Thomson. So these were the limitations, and due to which we can say that another one scientist came into the same one field and he proposed another one nuclear model. इसके साथ साथ yes, Thomson का जो model था, there was no experimental proof also of that model, and that's why Rutherford brings a nuclear model, or we can say the alpha scattering experiment, which proposed a model for an atom. So Rutherford and his students beta basically bombarded. This is, just have a look here, this is the gold foil, and there are the alpha particle. This is the radioactive source. ये क्या था आपका? ये radioactive source था, and it passes through the slit तो जब ये रेडियो एक्टिव सोर्स, ये रेज यहाँ से इस स्लिट से पास होकर के इस गोल्ड फॉयल पर डलती थी. सो एज यू कैन सी हियर दैट, ये देखिए बेटा, तो ये जो थी, ये पीछे एक जिंक सल्फाइड की स्क्रीन थी. क्या थी? There is a circular screen of zinc sulfide and it was observed that the fluorescent, ये देखो यहाँ पे fluorescent mark, कुछ रेज जो थी वो ज़्यादातर maximum number of the rays they pass through this gold foil and attacking at this portion, but few of the rays they deviate their path and come on this. यहाँ भी आ रही हैं कुछ जो थी, ये ऑब्जर्व किया गया कि कुछ स्लिट में एटलीस्ट यहाँ पर भी पहुंचे, वापस भी आ गए. तो इट मीन्स कि there were the three types of rays observed produced by these alpha particles, or we can say there is the with the tiny flash of light was produced at different points. ठीक है. So thin gold foil was used and zinc sulfide screen around the foil that is to be used in this experiment. Okay. So the result of this experiment were unexpected, that it was observed. जैसे बेटा ये है, तो ये सोर्स ऑफ अल्फा पार्टिकल्स था, ये बीम ऑफ अल्फा पार्टिकल्स है, ये हमारी गोल्ड फॉयल थी, और ये जो थी क्या थी? फ्लोरोसेंट स्क्रीन थी. So in this one it was observed this, as I have shown in you the previous one figure also. The maximum number of the rays passed through the gold foil. Few of them they deviated their path, means they were not traveling in a straight line, but they little bit deviated their path like this, and few rays were expected to revert back. ये जो थी कुछ revert back दी हुई. So most of the alpha particles passed through the gold foil undeflected. काफी सारा particle जो था वो undeflected क्या हो गया? सीधा निकल गया. A small fraction of alpha particles was deflected by small angles. कुछ ने small angle से deflection show किया. Very few, means 1 in 20,000 alpha particles, they bounced back, and that is deflected nearly by 180 degree. तो कुछ ऐसी थी जो कि क्या हो गई? बिल्कुल 180 डिग्री पे वापस चली गई. ठीक है. So that happens like alpha particles. तो यहाँ पे आप देख सकते हैं कि this is nucleus, और ये इस तरीके से कुछ ये न्यूक्लियस के पास जाकर के वापस हो गई, कुछ जो आउटर स्पेस था न्यूक्लियस के बाहर वाला, वहाँ से सीधा विदाउट डिफ्लेक्शन आराम से अनडिफ्लेक्टेड होके स्ट्रेट लाइन पाथ ट्रेवल की, एंड फ्यू ऑफ देम विच कम नियर टू द ओरिजिन ऑफ न्यूक्लियस दे डेविएटेड देयर पाथ. ठीक है. So on the basis of these observations, Rutherford come to the conclusion that most of the space in atom that is empty. Why? Because most of the alpha particles passed through the foil undeflected. ठीक है. Very few positively charged alpha particles were deflected. बहुत कम. Deflection must be due to enormous repulsive force which is shown by the positive charge of the atom, or we can say the nucleus, which is not spread throughout the atom, which is spread at a particular region of an atom, and that is later on known as nucleus. ठीक है. तो ऐसा जो कि थॉमसन ने भी प्रिज्यूम्ड किया था, the positive charge has to be concentrated in a very small volume that repelled, जिसमें कि रिपेलिंग हुई, और जो रेज थी वो सीधा 180 डिग्री पे रिवर्ट बैक हो गई, एंड डिफ्लेक्टेड द पॉजिटिवली चार्ज्ड अल्फा particles. ठीक है बेटा. So calculations by Rutherford showed that volume occupied by the nucleus that is negligibly small as compared to the total volume of the atom. And radius of atom जो था that is about 10 minus 10 meter. तो nucleus जो था उसमें से 10 raised to the power minus 15 मीटर का था. तो उन्होंने मतलब इतना appreciation तक दे दिया था कि that is going to be there by realizing that अगर हम कहें कि एक क्रिकेट बॉल जो है वो रिप्रेजेंट न्यूक्लियस को कर रही है, ठीक है, तो रेडियस ऑफ एटम जो होगा दैट विल बी अबाउट 5 किलोमीटर. अगर एक क्रिकेट बॉल है तो वो क्या है आपका, दैट रिप्रेजेंट्स अ न्यूक्लियस. तो उसके सराउंडिंग का जो 5 किलोमीटर का रीजन होगा that is going to be considered as the, sorry, just 1 minute, ठीक है, that is going to be represent a 5 kilometer region that represents a radius of atom. So जैसा कि अभी हमने conclusion की बात करी तो वो ये थे कि most of the mass of the atom was densely concentrated in the extremely small region, and that small region is of a positive charge which known as the nucleus. ठीक है, nucleus जो था that was surrounded by the electrons moving in a very high speed in circular paths which were known as orbits. And Rutherford model of atom resembles the solar system, बिल्कुल solar system की तरह resemble करता था, in which nucleus plays the role of sun. nucleus किसका रोल प्ले कर रहा था, sun का, और जो electrons थे that plays the role of revolving planets. ठीक है, electrons and nucleus they are held together by the electrostatic force of attraction, as and sun and planets are held together by the gravitational force of attraction. ठीक है, now the limitations of Rutherford. So सबसे पहली बात that जैसा मैंने कहा कि gravitational force से वो थे, तो that could not explain the gravitational force in nature. Second one, planetary motion under the influence of gravity जो होता है वो नहीं explain कर पाया. Third one, Maxwell की जो electromagnetic radiation property थी, इस concept को Rutherford model was not able to explain. Rutherford model as well as was not able to explain the stability of an atom. एटम की स्टेबिलिटी कैसे होगी वो भी नहीं बता पाए. इट also was failed to explain the distribution of electrons around the nucleus. कैसे होंगे, कितने कितने कहाँ पे पाए जाएंगे, and about the energies of these electrons ये भी नहीं बता पाया. as well as that was not able to explain the quantum mechanics. Okay, so these were the drawbacks of Rutherford model of atom. Now beta, there is atomic number and mass number. You must have studied about this in your 9th standard, but I just want to revise it once again because it is going to be used in this chapter a lot. So as all of us we know that the number of protons which are present in the nucleus is equals to the atomic number, or we can say atomic number which is represented by Z is equals to the number of protons present in the nucleus or number of the electrons in neutral atom. I'm not talking about the ion, I'm talking about the neutral atom. Electron and proton, not these are not electrons, these are neutrons. ठीक है, neutrons and protons together in a nucleus. ठीक है, क्या, in a nucleus known as nucleons. Total number of nucleus is termed as mass number. Means mass number is nothing. Mass number is the number of proton and number of neutron, whereas the mass number is denoted by symbol A. ठीक है, नेक्स्ट एक इस टर्म्स और आप लोगों के साथ यूज होगी, दैट इज isobars and isotopes. So isobars are the elements which have same mass number but different atomic number, whereas isotopes are the elements which have same atomic number but different mass number, like hydrogen, that is having 3 isotopes, that is protium, deuterium and tritium. और अगर मैं बात करती हूँ आपकी isobars की, तो isobars are your argon, and calcium. ठीक है बेटा? Argon and calcium are the isobars because both of them having a 40 mass number, but argon is having a atomic number 18, whereas calcium is having a atomic number 20. Hydrogen के 3 isotopes होते हैं, protium, deuterium, tritium. All of these having a same atomic number, that is 1. But if we are talking about the mass number, so protium is having a mass number 1, deuterium is having a mass number 2, and tritium is having a mass number 3. Chemical properties जो atoms की होती हैं, that are controlled by the number of protons and present in the nucleus, or we can say the number of electrons in the atom, as they show similar chemical properties and similar chemical behavior. So today we studied about the various atomic model, that is of a Thomson atomic model as well as the Rutherford. What are their observations and what are the limitations? Students, just go through the topic again, and thank you.